Today, we are going to complete this. I'd like to do these 2 questions. So you can get them on Avenue to Learn. I just posted them up today. So let's look into, we started this question before, okay? I explained to you what is going on, okay? It's one of those questions that you have to carry out optimization. So I'm going to change things slightly. There are some values that we have found on yesterday. We can still use them. But what I'm going to change now is these values over here, okay? So we are going to state that the stress max is equal to 130 megapascal. The dimension over here is 590. And then on this side is 550. Okay. So just to quickly recap, the formula that we're going to use is shear stress is equal to Vy over Izz Qz over T. So remember the 5 rules that I told you guys about. Okay, we're going to apply all the 5 rules over here. Okay, we can't break any of them. But what we're going to do first, we're going to, so rule number 1 is that V and Izz are constant. So we are going to determine Izz, okay? So if we were to sketch our transformation, this is our X, and this is our Y. On the cross-sectional view, this will be our Y, and this will be our Z. Okay, that is our cross-sectional view. So from here, we know that Vy is coming down in the vertical direction. That's where we have to determine Izz. So Izz is the first moment of second moment of area about the what? ZZ axis. So Izz, I'm going to do it this way. You can do it whatever way you want, but I'm going to do Izz is equal to the width. So we know that ZZ is an axis of interest. Immediately, we know that this is our width. And this direction, this is our depth. There's a width or depth. So my width is going to be 50. Depth is 40, 100, 120 cube over 12. So what this means is I'm taking the solid. Okay, I will adjust the volume microphone. Daniel, sorry, I'm going to turn it down. Okay. So you hear me? Better now? Yeah. Oh. Then I'm going to minus off. Okay, I'm going to minus off the 2 squares. Okay, I'm going to take away the 2 squares. Okay, so the 2 squares, so I will have a big 2 down here. And my width is 30. My depth is 30 cube over 12 plus by the area of the squares. And then this will be equal to 20 or 40 divided by 2 plus by 30 divided by 2. 40 divided by 2, just to elaborate, is this section over here, 40 divided by 2. 30 divided by 2 is this section over here, 30 divided by 2. Very clear, okay? Nothing like shocking or unexpected. I think you guys are really good at this now. So now, this will be equal to 50 times by 120 power 3 divided by 12. 7.2 times 10 to the power 6 minus by 20 plus by 15. There's a square down here. Okay, 20 plus by 15 squared times by 30 times by 30 plus by 30 power 4 divided by 12. 1.17 is it 1.17 times 2? 2.34. Okay, 2.34 times 10 to the power 6. So the second moment of area is 4.86 times 10 to the power 6 millimeter to the power 4, 4.86 times 10 to the power minus 6 meter 4. So the second moment of area, we got it by taking the whole thing, okay, and then minus off. So these are the hollow squares. This is the solid rectangle. Okay. So the next thing we're going to do is we are going to determine our Q values. Okay, so we have our IZZ. Okay. This question, what we will like to identify is we want to find what is our Vy. We don't know what is our Vy. Okay, we don't know, right? So for these questions, if you see down here, we are going to determine the largest what? P. Vy, we don't know. Okay. What we do know is the shear stress, which is 130. We have found our IZZ. Next, we are going to determine our QZ. Okay. So we have determined QZ on yesterday, but this was quite chaotic. I will do it again. Okay, I will do it again today. So we are going to determine our QZ. I'm going to turn this down. Okay, I'm going to divide this into section. Okay, so I'm going to divide this into section like this. Okay, and this is our centroid. So over here, I would like to label this as our top flange. Then we have our webs. And then I'll call this our lower flange. We only consider up to that section is because of what? The first moment of area cannot cross the what? Not cross the centroid. It was the term that ended. Okay. So you cannot cross the centroid. Okay. So from here, you're going to get it worse. That's what he's thinking. Well, anyway, so we're going to determine the first moment of area. So we're going to determine our QZ. And QZ is equal to A y bar. Okay. So we're going to consider the QZ of the top flange. So the width, so what I like to do, the area, right? I like to go to width, depth, y bar. Okay. So the width over here is 50. The depth is 10. The y bar is 20 plus 30, 50, 60 plus or minus by 10 divided by 2. Okay. So this is equal to 60 minus 10 divided by 2 times by 50 times 10. So it's 2.7 times 10 to the power 3 or 27 times 10 to the power 3 millimeter cube, and is also equal to 27.5 times, let me put this 27.5 times 10 to the power minus 6 meter cube. Then we are just going to consider the QZ of the web. So we just look at the web section. If you look at how this is divided, we just focus on the web section now. For the web section, you have left and right. We have to consider the two. The width is 10. The depth is 30. And then it is 20 plus by 30 divided by 2. So this will be equal to 2 times 10 times 30 plus by, not plus, seriously, times by 15. So let me do it again. 20 plus by 30 divided by 2. That's by 30 times 10 times 2 is 21. Okay. So this is equal to 21 times 10 to the power 3 millimeter cube is 21 times 10 to the power minus 6 meter cube. Okay. So these values are important. Then we look at the QZ at the lower flange. So the width is 50. The depth is 20. The y bar is 20 divided by 2. Okay. So it's equal to 10 times 10 to the power 3 millimeter cube. This will be equal to 10 times 10 to the power minus 6 meter cube. At this moment, you all should be really like familiar on how to get the second moment of area. Before I go on, how many term tests you all have next week? What are the two? Calculus is when? You guys are fine. Okay, so focus on this. Okay, you got 3 days to do calculus. Okay, you got 3 days to do calculus. Okay, so focus on this. Focus on this. Okay, calculus hard course or pretty straightforward? Pretty straightforward. Okay, this is more crappy. So focus on this one. Right. So now I know we already know the answer already. I'm gonna make the picture bigger. So yesterday we spoke about the ratio, right? Yesterday we spoke about the ratio of QZ over T, yes or no, to determine position of tau max. So there are two areas of concern. I will now call this our point A, and I'll call this region down here our point B, right? And what we know at point A, right? At point A, T is at its what? Minimum. The thickness is at minimum. At point B, why we pick point B? Because Q is at its what? Maximum. Yes or no? Okay. So let's focus on point A. Okay, let's focus on point A. So shear stress at point A is equal to Vy over Izz. We know this is constant. We don't need to put in any values at all. Then we need to find Qz at point A. The thickness we do know. The thickness is twice of 0.01. Agree? So Qz at point A will be equal to what? Okay, so will be equal to Qz of the top flange plus by Qz at the what? at the web. Okay. Now, when you look at the solution manual, some question they split this into half this way. Don't do that. It will confuse you like hell. Okay, don't do that. Okay, just focus on how I'm teaching you. So from here, QZ on the top flange, if I quickly refer back, it's 27.5. Okay, 27.5 times 10 to the power minus 6 plus by 21 times 10 to the power minus 6. We add this up. Okay, 27.5 plus by 21. We have 48.5 times 10 to the power minus 6 meter cube. Then we calculate our shear stress at point A. This is equal to Vy over Izz. Qz, we know that is equal to 48.5 times 10 to the power minus 6. And then we divide by twice of 0.01.